In this lecture, we are going to continue working on the enemy's attack behavior. For now, we've got the attack task and the patrol task working in the behavior tree. Next, we are going to add the attack animation. Then we're going to write some blueprint to make the enemy damage the player. First, let's stop this simulation and go back to the enemy blueprint. In the enemy blueprint, we have created an attack event in a previous lecture. This event is going to play the attack animation, so we just need to call this event from the behavior tree. Let me comment out this event first. I'm going to say this is going to play the attack animation, and this function is called from the behavior tree. Alright, that's it. Now let's switch to the behavior tree. We are going to add a new task under the attack node, and the task has to be placed to the left of the wait task. So we need to create a new task first. Let's hit the new task button, then select blueprint base. Keep the file in the AI folder. I'm going to call it bt task underscore enemy attack. Alright, now we have a new enemy attack task. We want to call the attack event from the enemy blueprint whenever this task is executed. So let's override the receive execute AI event. This event is going to get called once the attack task gets started. Let's drag out from the control pawn, which should be the enemy blueprint. To access to the attack event, we need to cast it to our enemy blueprint. Then we can call the attack event. After this, we want to tell the behavior tree that this task is finished, because this task itself only plays the attack animation, and the duration of this task is only going to be like 1 frame. So we need to jump over to the wait task. That's the way we can tell the behavior tree to wait until the attack animation is finished. So let's drag out from here and call the finish execute function. Be aware that the success input has to be true. So let's enable it. Otherwise, the wait task to the right is never going to run. Alright, we are done with the attack task. Let's go back to the behavior tree. Drag out from the attack node to call the attack task we just created. Make sure the attack task is to the left of the wait task. Let's recap. We play the attack animation here. Then we wait until the animation is finished. Let's open the enemy animation source to check out the duration of the attack animation. Let's select enemy attack. Then we can open the enemy attack flipbook from the right side. You can see the frames of the animation is from 0 to 14, which means the animation is 15 frames long. And it's also playing at 15 frames per second, which means it takes exactly 1 second to play this animation. Alright, let's go back to the behavior tree. For the wait task, the wait time is 1 second. We can try to decrease it to just a half second and see what is going to happen in this case. You can see the attack animation is playing, but it never gets to finish because the wait task is too short for the animation. Alright, let's go back. I actually want the enemy to wait for just a little bit longer. So let's set the wait time to 1.5 seconds. This way, after the animation is finished, the enemy should pause for a very short moment before it starts the next attack. Alright, let's test the game. Looks good. Now the enemy can finish the attack animation, and then it will pause for half a second. Then it'll start the next attack. Next, we want the enemy to actually damage the player. To do this, we need to add another collision shape to the enemy. Let's go to the enemy blueprint, switch to the viewport, and go to the 2D view. Let me zoom in a bit. Now let's add a hitbox that will only be enabled during the attack animation. Hit the Add button, then search and add a capsule collision. I know this is going to be called a hitbox, but I feel like a capsule might be better since we already have the player detector box here. So having two boxes here might make it very confusing. That's why I chose to use the capsule collision here. Let's change its X location to 44, so it's in front of the enemy. Next, I'm going to change the capsule half height to 48 and the radius to 41. Also make the line thickness 0.5 so we can see this capsule better in the game. Maybe also a unique color. I'm going to set it to red. Alright, then let's rename this capsule to player hitbox. We're only going to enable it during the attack animation. Then it's going to damage the player if the player is inside the area. Alright, next, let's go set the collision presets. Let's select the player detector preset. This is the preset that we used with the player detector box. And by using it, we get the same settings down here. So this one is also only going to interact with the player. Next, we need a way to enable it and disable it from the attack animation. So let's go to the event graph. And we are going to create two custom events. Let's create the first one here. Just enter the overlap event. Search for add custom event. Let's name this one to enable hitbox. Then let's add another custom event. Let's call this one disable hitbox. Alright, next, let's drag in the player hitbox we just created. Let's drag out from the hitbox. Then we need a function called set collision enabled. This node is going to enable or disable the player hitbox for us. Let's set the new type to no collision and connect the disable hitbox event to this one. Then we can copy and paste this function again. Connect the enable hitbox event to it. But we have to make sure the new type is set to query only, because in this case, we want to enable the hitbox. Also, don't forget to connect the hitbox to the target input. Next, to help us visualize the state of the hitbox, let's make the hitbox show up in the game when it's enabled. So we use the set hidden in-game node, and we make sure the new hidden is unchecked. So the hitbox is going to show up in the game. Let's duplicate this node again. Connect it to the disable event. Also connect the hitbox to the target input. This time, we want to enable new hidden. So the hitbox is going to disappear in the game when it's disabled. Let me reroute to keep the graph tidy. Alright, we are done here with the events. Let's just comment them out. I'm going to say these are to disable and enable the player hitbox from the attack animation. One last thing to do here. We want the hitbox to be disabled when the game starts. So let's go find the event begin play. Let's call the disable hitbox event from here. Alright, we're all set here. Next, let's go call the event from the animation. Let's go to the enemy animation source. I have the window opened already, but if you don't, you can open the enemy animation source here in this folder. Alright, let's go back and select enemy attack. Let me pause the animation. In the timeline, let's go to somewhere around the 10th frame. This is when the enemy smashes down. We are going to add a notify blueprint at this frame in the timeline. But first, you need to expand notifies. Then you can see you have the track number 1, and you need to right-click on this number 1 track. Alright, here I'm going to create a notify, but you don't need to follow me here, because I'm just making a quick demo to show you why this notify is not the one we need. I'm gonna select add notify, then new notify, and we can call this one test. Alright, actually we don't need this test notify. I just added it here to explain why this one is not what we want. You can see this is just a 1-point notification, so it just happens once at this frame. But we have the enable and disable events. So what we need is a notify that contains a start point and an end point. And this one doesn't suit our needs. So let me remove it. I also need to open the source notifies window to delete the test notify object. And of course, you don't need to follow me here if you don't have it. Alright, the quick demo is finished. Let's get back to work. What we actually need is a notify state, but we cannot create it here in the timeline. Instead, we need to go to the content drawer to create the file first. Let's right-click in the enemy folder under the animation folder. Select Blueprint class. Let's search for paperzd notify state. let's select this one. I'm going to name this one to enemy underscore enable player hitbox. Alright, let's go back to the enemy animation source. Right-click at around the 10th frame. Select Add Notify State. Then we can select the new state we just created. Alright, now we have the notify state in the timeline. We can drag to stretch this state. Let's stretch it to around the 13th frame. So this covers the period where the enemy's hands smash down. To call the hitbox events, we need to open the notify state file. Here, let's override two events. Let's go to the left side. Click here and override the onNotifyBegin event. This event gets called when the notify state starts at around the 10th frame. And we have the only instance here. But this is not the enemy blueprint. This is actually the animation blueprint. To get the enemy blueprint, let's stretch out from it. Then we call the getOnlyActor function, and we cast it to our enemy blueprint. Then we connect the event to the cast function. Alright, now we can drag out from the enemy and call the enable hitbox event. This is going to enable the hitbox at around the 10th frame of the animation. Let's copy these two nodes and go override another event called onNotifyEnd. Let's paste the two nodes here. Then connect the event to the function. Also, don't forget to connect this target. Alright, this time, let's call the disable hitbox event. So this is going to disable the player hitbox in the enemy when the notify state ends. Let's compile and go back to the animation source. I just want to review where we should place the notify state in the timeline. Alright, let's save everything. Now we can close this animation source window and go back to the level to test. If everything works, you should see the red capsule collision shape pops up when the enemy smashes the ground, and then it should disappear. Alright, now the hitbox works very well on my side. Next, we should apply some damage to the player when the player is inside the hitbox. Let's switch back to the enemy blueprint. Select the player hitbox. Then scroll down on the right side. We want to add this onComponentBegin overlay event. Before we apply the damage to the player, let's try to print out a message to make sure everything is working. Let me call the printString function. Then connect the other actor output to it. Let me read out and we can test. Looks good. We get the name of the player whenever it's hit by an enemy. Alright, let's stop here and go back to the enemy blueprint. Delete these nodes. Drag out from the other actor. We need to cast it to our player blueprint first. Then we drag out from the BP player and call the apply damage function on it. I think this is a built-in function from the character class. It doesn't really damage the player when we call it. It's sort of like just notify the player that it's being damaged and passing over all of the necessary information. As you can see here, we can pass the damage number. We can also pass other information like what is the actor that is causing this damage. But for now, we don't need to pass over any information. We are going to start working on the health system from the next lecture, and that is when we handle the damage. For now, let's go to the player blueprint, because I want to make sure the player is receiving the message. I think we don't need this update flipbook node. Let me move it aside and comment out. Maybe change the color of the comment. Alright, let's get back to work. Let's overwrite an event. It's called event anyDamage. This event is going to be triggered when the enemy calls the apply damage function on the player. To test if this is working, let's just print out a message. Alright, let's compile and go back to the level to test. But the message is not showing up. After spending some time, I found out that this is because when we call the apply damage function, the base damage is set to 0. So let's switch to the enemy blueprint and set base damage to 10. Alright, now let's compile and test again. Great, this time it's working. And this wraps up the lecture.